Let's look at how to find inverse functions. To begin with notation, the inverse function of f of x is written as f inverse of x using a -1 to indicate the inverse. Now the idea of a function is to take an input, which we call x, apply some operations to it, and then obtain an output, which we can call f of x. And the idea of an inverse function is the opposite, in that we take our output and then consider what operations we need to apply to that so that we end up with our input of our original function. Let's look at some examples. So we're going to find the inverse function of the following. The first function says f of x equals to 2x squared minus 7. We first start by replacing f of x with y, and so we can write y equals to 2x squared minus 7. Now because we're doing the opposite in finding the inverse function, we swap x and y over and then rearrange for y to obtain our inverse function. So swapping x and y over gives us x equals to 2y squared minus 7. And now rearranging for y, we can first start by adding 7 to both sides, which gives us x plus 7 equals to 2y squared. We can then divide both sides by 2, which gives us x plus 7 over 2 equals to y squared. And then finally we can take the square root of both sides, which gives us the square root of x plus 7 over 2 equals to y. And so the inverse function of f of x is the square root of x plus 7 over 2. And so we can replace y with the inverse notation, which finally gives us f inverse of x equals to the square root of x plus 7 over 2. The second example says g of x equals to the square root of x minus 2. So again, we can start by replacing g of x with y and writing this out as y equals the square root of x minus 2. And now since we're trying to work out the inverse function of g of x, we're going to swap x and y over, which gives us x equals to the square root of y minus 2. And now we're going to rearrange for y. So we can take the square on both sides, which gives us x squared equals to y minus 2, and then add 2 to both sides, which gives us x squared plus 2 equals to y. And since we've now rearranged for y, we can replace this with the inverse notation for g of x, which gives us g inverse of x equals to x squared plus 2. And this is the inverse function of g of x. The third example says h of x equals to 7x plus 7 all over 8. And so we can start by replacing h of x with y, and so writing this out gives us y equals to 7x plus 7 all over 8, and then swapping over x and y again to give us x equals to 7y plus 7 all over 8, and then rearranging for y, so we can start by multiplying both sides by 8, which gives us 8x equals to 7y plus 7. We can then take away 7 from both sides, which gives us 8x minus 7 equals to 7y. And then finally we can divide both sides by 7, which gives us 8x minus 7 all over 7 equals to y. And so using the inverse function notation, we have h inverse of x equals to 8x minus 7 all over 7. The final example says f of x equals to x over x minus 1. We start by replacing f of x with y, which gives us y equals x over x minus 1. We then swap over the x's and the y's, which gives us x equals to y over y minus 1. And now we rearrange for y. Now in this example, because y appears more than once, we know that somewhere in our working out, we need to factorize y. We can start by multiplying both sides of the equation by y minus 1, which then gives us x brackets y minus 1 equals to y. We can then expand the brackets out, which now gives us xy minus x, which equals to y. And then we can minus xy from both sides, which gives us minus x equals to y minus xy. And now because the terms that have y in them are both on the same side of the equation, we can factorize the y out. And so we end up with minus x equals to y brackets 1 minus x. And so finally, dividing both sides by 1 minus x gives us minus x all over 1 minus x, which equals to y. And so using our inverse notation, we have that f inverse of x equals to minus x over 1 minus x. Now with this example, alternatively, we could have got the following. So taking the line xy minus x equals y, we have, instead of subtracting xy from both sides, we can add x to both sides, which gives us xy equals to y plus x. We can then subtract y from both sides, which gives us xy minus y equals to x. And now, because the two terms that have y in them are both on the same side of the equation, we can factorize y out. And so this gives us y brackets x minus 1, which equals to x. And then finally, dividing both sides by x minus 1 gives us y equals x all over x minus 1. And so using inverse function notation, we have f inverse of x equals to x over x minus 1. Both of these answers are correct for the inverse function of f, because if we take f inverse of x equals minus x over 1 minus x, and we multiply the numerator and denominator by minus 1, we then obtain our inverse function written in this format, because minus x times minus 1 is x, and 1 minus x times minus 1 would give us 1 times minus 1, which is minus 1, and the minus x times minus 1, which is plus x. And so rewriting this would give us x over x minus 1, which we have here. The reason we might obtain the inverse function with opposite signs is due to the rearrangement for y, and whether we rearrange using this first method or the second method. But equally, both of these answers are the same and correct.